at revision questions in power Jamb physics class. Do you understand? So these questions here you are seeing, they are selected from the Jamb past questions. So these are type of questions Jamb normally ask in physics when it comes to what power. Just as so you want to stick to the end of this video here. I've not only solved the question here, but I also give you what the various formulas you can use to solve what power. I have done a complete video on power before, but this is just like a revision video where I explain some questions Jamb normally ask under what power. So you want to stick to the end of this video. If you are new here, please consider subscribing so that you will not miss out any other video I'll be dropping like this. Because my intention here is to what produce video like this, revision question under what each of the topic in what Jamb examination. I don't know if I'm going to get to the end, but if for example now you want to take it privately one-on-one on physics, maths, and chemistry, write me up so I can what join my private one-on-one class. But it's not free; you have to pay. Just so we want to stick to the end of the year. So let's look at what the first one here. Before we look at this question, now I want to understand something here. Let's look at what power, right? What about power? Power is equal to what? The rate at which work is done. Right there, the rate at which work is done. That is what power. The rate at which what work is done. Or you can say power is defined as the rate of doing work. Just and or you can say power is what is the rate of doing work. So yeah, when you look at power, we talk about what work over what the time. Because when we talk about rate, this is what with time, how fast it's moving. Do you understand? So power equals to work over what time. The unit of work is what it shows, and unit of what time is what is seconds here. So power can be just per what seconds. Just per seconds also the same thing as watts. As what. So these are things you need to understand here. Now, but we know that work is equal to force times distance, right? Or force times displacement. So you can say you can break it down force times distance over what time. Do you understand? So it's a question here. Work will not be given to you. Do you understand? So you have to what break it down to force times what displacement, right? Now remember, when we talk about displacement over time, you're talking about what velocity. So here you can say F times displacement over what time, right? Do you know what is velocity? So you can say F what V. Do you see that? So power can be what work over time, or can either be force times distance over time, or force times velocity. Do you understand? So these are what various formula you need when it comes to what work. Do you understand? And you cannot be talking about work when you cannot talk about the efficiency of the machine. Just that because what like we talk about power, we're talking about power, you're talking about what the machine you are using to do the work. Do you understand? Very important. So we talk about efficiency. Efficiency, which is this here, efficiency is what is power input. So power output over what power input. Do you understand? So you can say power output over what power input times what 100 over what 1. Do you understand? Now power output is the work you have done, the work you produce. Do you understand? The work you produce. Why power input is the amount of work you put in to produce the work. Do you understand? So this is it here. So you have to taking of this formula and this formula here. So you can just say efficiency is equal to what P over Pi times what 100 over 1. So these are the various formulas used when it comes to what power. So please understand this here, because these are stuff you are going to use in solving this question. So pause the video and copy it out. If this video is helpful, please leave a message that this video is helpful, and kindly subscribe to this channel if you have not done that, so that you not miss out any other video I'm producing on this YouTube channel, right? So you can also share this video with your friends who are also writing the upcoming Jamb examination. So let's look at what the first question. The first question is a little bit technical, but let's look at the first question here. A load of mass 120 kg is raised vertically through a height of 20 meters in 30 seconds by a machine whose efficiency is 100. Calculate the work generated by the machine. Please look at something. Work generated by the machine. What does it mean? Work output. Work generated by the machine is what is the work output. Do you understand? Because I ask you work generated by the machine. So yeah, my efficiency, I will from this place I will explain so many things for you. So please pay close attention here. So yeah, my mass is what is 120 kg, right? Now the height at which it is being raised, which is the distance, is what is 20 what meter, right? And the time is what is 30 what seconds. Now they gave me what efficiency here. Efficiency of a machine is what is 100. Now there's one thing I want to explain here. When the efficiency of a machine is 100%, that is the work input is equal to what the work output. Just there are things you need to know here. When the efficiency of a machine is 100%, the work input is equal to what to the work output. Just so now they're asking what is the work output? No, like the power output, right? Power what output? Yes, which is what they're looking for here, right? Power what output here. From this parameter, say I want to get the power what input, the power what input zero. So these are things you put into the machine. Now the load is what is 120, the vertical height is 20, and the time it takes is what is 30 seconds. So it is the input. Just so you want to get the output. Just very important. So yeah, remember efficiency is equal to what work output over what work input times 100 over what 1, right? So let's get the work input, right? Remember, no, sorry, what am I saying? Work power output. Power output is what? Remember, I told you that is work over what time, right? And work you can split it down to what force times distance over time, right? Equals to what mass times g times distance, right? Over what time? Do you understand? Because here, what happened here is that force is not given to me, right? But they gave me what? They gave me the mass. So I'm going to use g, right? Because when we talk about force, when it comes to what vertical height here, force when it comes to vertical height is what we are using what as relation to gravity. Do you understand? So it's going to be mg times d over t. This is that. So this is how I got what my power input equals to what my mass is what is 120 times my g is what is 10 times my d, which is what the height, right? 2 over what my time is what is 30. This is that. So what I want to do here is to what input what my values here. So I put my values here. We have 120 times 10 times 2 divided by what 30. Here we have 80. Here we have what 80 watts. 80 watts. It's okay, 80 watts. Now, but if you check very well, the efficiency of the machine is 100%. So whenever the efficiency of the machine is 100%, normally if it's not 100%, you have to use on here. But whenever it's 100%, whenever it is 100%, please, there's something to understand here. When it's 100%, work input is equal to what work watts. So power input is equal to what power watts output. Just they are the same. So that is my power output is also the same type of power watt input. You go to the 80 watts. Hope you understand. You can see how easy it is. It's not difficult. It's very, very easy here. Do you understand? It's very, very easy. So these are what the calculation here. All these I hope you understand. If you understand, please leave a message that you understand. Let me tell you what question 2. Question 2. You should pause the video here and try this question 2 and see if you are going to get the answer. Pause the video and try this question 2 and see if you are going to get the answer or not. Let me see what you can do. Pause the video and try it. Pause the video and try it. Pause the video and try it. Right? So a man of mass 50 kg has sent a flight of stair 5 meters in 5 seconds. If the acceleration to gravity is 10, what is power expanded? Very easy, right? I've already done it on here, right? Power, remember I told you that power, as a Jamb student or as a physics student, you must try as much as possible to derive the formula for each of the formula. It's very important. You have to know them well. Power equals to what? Work over the time. Work over what? Time, right? And what is work? Work is equals to force times distance over what? My time, right? Now if you check there where they gave me what? The mass, one. They gave me what? The distance, and I have what? The seconds here, right? So I have to break this guy down. So it's going to be what? mg times d over what? My time, right? So you can see that my power is equals to what? What is my mass? 50 what kg? 50 what kg times. So let's just leave the unit here. Times. Yeah, my g is what? Is 10 times my distance is what? Is 5 meter over my time is what? Is 5 seconds, right? So you have 50 times 10 times 5, right? That by what? 5. Give what? 500. 500 watts. 500 watts. 500 watts. Is okay. So the work expanded is what? Is 500 watts. That is it. So question 3. Let's have question 3 here. A man weighing 800 newton climbs up a flight of stairs to a height of 15 meter in 12 seconds. What is the average power of output? Very easy. It's still the same thing here, right? Which formula are we going to use there? So we are going to use this one here. We are using what? The second formula here, right? Here we have the first one, here we have the second one, here we have what? The third one, right? Now if you check very well, they gave me what? The force, right? They gave me what? The height, and they gave me what? Seconds. So here I can say that power is equals to what? My force is what? Is 800 times my distance is what? Is 15 over my time is what? What is my time? My time is 12 seconds. Now let me ask you here, what about if this time is what? Is in hour or minutes, right? You have to convert to what? To seconds, and I believe you know how to do that, right? Then use your calculator to get your answer. 800 times 15 divided by what? 12. What is the answer? 1000. Here we have 1000 watts. 1000 watts. That is the answer here, right? So let's look at what? Question 4. So we have done question 1, question 2, and what? Question 3. Question what? 4. Let's look at what? Question 4. So let's look at what? Question 4 here. Question 4. Please pay close attention here, because sometimes these questions are very, very confusing, right? An electric water pump rated 1.5 kilowatts lifts 200 kg of water through a vertical height of 6 meters in 10 seconds. What is the efficiency of the machine? Please understand this question very well. So that whenever I see this kind of question in the exam, you'll be able to answer it and get the correct answer. Now, on that thing, I want to show you. Whenever I see a question, when you make the wrong move, or when you make a mistake, you know. I will tell you how to know that. Just but look at something here. Let's look at this again. An electric water pump rated 1.5 kilowatts lifts. So this is the power input, because it is this work that lifts this 200 kg of water through a vertical height of 6 meters in what? 10 seconds. Just so this power you're seeing here is called power what? Input. This is the work input to do the work, to get what? The work out, to get the work output. Just so here we have power what? Input is equal to what? 1.5 kilowatts. Now why is it the power input? Because it's that an electric water pump rated 1.5 kilowatts lifts. So it is this one that lifts the work, that lifts it. Hope you understand. Lifts 1.5 kilowatts, right? Now, the station will calculate the efficiency of the machine, right? The efficiency of the machine. So remember, for us to get the efficiency here, we need to get what the power what output. This that. So how do we get the power output? By using all this one here. So my power output here equals to what? The force, the work over what? Time, right? Then force times distance over time equals to what? Mg times distance over what? Time. Do you see that? So here we go to be your power output here equals to what? My mass is what? Is 200 times my G is what? Is 10 times my height is what? Is this which what? 6 over how many seconds? 10 seconds here equals to what are you going to get? This will cancel out this one here. So you have 1200 watts. 1200 watts. Do you see that? So if you check very well, they gave me what? Kilowatts. Here is what is watts. So this is what I would do here. I will convert this one to what? To kilowatts. So I will have kilowatts and kilowatts. Just how do I convert watts to kilowatts? By divided by what? 1000. If you divide them by 1000, what are you going to get? You're going to get 1.2 kilowatts. Just now, you're going to get 1.2 kilowatts. Just now. So my power output now you're going to be what? 1.2 kilowatt watts. Do you see that? From this what? So that kilowatts is going to be kilowatts and kilowatts, right? So now what's my efficiency? My efficiency is what? Equals to what? Power output about power what? Input times what? 100 over 1, right? So let's input your power output is what? 1.2 kilowatts over 1.5 kilowatts times what? 100 over 1, right? So kilowatts and kilowatts with what we cancel out here. So what do I have here? 1.2 times 100 divided by what? 1.5. Here we have what? 80. We're going to go 80 percent. It's okay. Now, but let me show you something here so you understand. Please pay close attention. In case you solve this thing here, probably you didn't know that they're going to be the power what? Input. Probably you thought that this one is going to be power output, right? If you should make the mistake of saying power output is what? 1.5 kilowatts. It's okay. Please pay close attention here. I now said power input is what? 1.2 kilowatts, right? If you should make this mistake, right? This is the answer. But if you should make this mistake, because most times you might make the mistake, do what will happen here. If you should try and solve it like that, that's going to be what? 1.5 or what? 1.2 times 100, right? 1.5 or 1.2 times what? 100. What are you going to get? You're going to get something like this. 1.5 times 100 divided by what? 1.2. 1.2. Here we have 125. There's no way efficiency will be more than 100%. So if you make a mistake and do like 1.5 or 1.2 times 100, right? You're going to get 125%. There's no way efficiency will be more than 100%. Just so these are things you need to pay close attention to. Then in anything you are solving here, the work input must be greater than the work output. Just the work. Look at something here. The work input must be greater than what? Work output. These are things you need to put in your mind when you are solving this kind of what? Question. Hope you understand. Please, if you have not subscribed to the channel, please kindly subscribe, hit that subscribe button, and turn on the notification bell icon because videos like this will coming up every single time on this YouTube channel. Maths, chemistry, and physics. Now, if you are still having issue with your physics, maths, and chemistry, and you want a private class, send me a DM that you need a private class. Then I'll tell you the amount you pay. Then you can start our private session. Just it's going to be of great help to you. I've done a complete video on chemistry calculation. I've done a complete video on organic chemistry. I've done a complete video on physics. Just so if you really want to pay, if you really want to cover this in your time, then come for private class. Then I will directing you what to do instead of you going around trying to watch random videos that you getting any significant result. Just join my private one-on-one class and you enjoy it. I bet you. Just thanks for watching. See you in my next video.